State Ohm's law. State Ohm's law. State Ohm's law. Ohm's law is relation between which two physical quantities? This Ohm's law is relation between which two physical quantities? Current and
Current and potential difference.
potential difference. Perfectly right. But the relation between these two is valid if external conditions such as temperature, length, area remains constant. So statement goes like this. You have done in I think 8th, 9th, 10th also. So long as physical, so long as physical state of conductor remains constant. So long as physical state of conductor remains constant, the current flowing through conductor, current flowing through conductor is directly proportional to the potential difference maintained across the conductor. That is I proportional V. Therefore, V proportional I. Therefore, V equal to IR. What is R here?
Constant of proportionality.
Very good. Superb. Called as resistance of conductor. Please copy till this, then I'm dictating further. This you have done in I think 10th also. So long as physical state remains constant, current flowing through conductor is directly proportional to potential difference maintained across the conductor.
Done, sir.
Until y equals to IR, then V equal to IR.
Yes, sir.
Where R is a constant, where R is proportionality constant, very correct. Called as resistance. Its SI unit is ohms. This symbol. Define 1. Define 1 ohm. Since R is V upon I, so I can say 1 ohm equals to 1 volt upon 1 ampere. 1 volt upon 1 ampere. So from this we can define this as space is not there. Okay, just copy these 2 lines. Below this you will write after 1 ohm is 1 volt upon 1 ampere. When potential difference of 1 volt is applied across conductor through which 1 ampere of current flows. When potential difference of 1 volt is applied through a across conductor through which current of 1 ampere flows, is said to have resistance of 1 ohm. Is said to have resistance of 1 ohm. Said to have resistance of 1 ohm. Conductance. What is meaning of resistance?
Obstructs the flow of current.
Obstruct the flow of current. That means oppose or assist. It opposes or it assists. Obstruct means what?
Opposes.
Oppose.
Opposes. So conductance should do what? Help or oppose?
Help.
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 So resistance का exactly उल्टा हो गया फिर तो ये.
Yes, sir.
Resistance is obstruction and this is assistance. So write down the reciprocal of resistance the reciprocal of resistance is called as conductance. Reciprocal of resistance is called as conductance. It is given by C equals to 1 upon R. Its SI unit is Siemens or omega raised to minus 1 or mho, MHO or ulta omega. हेलो सर मैं आपको बाद में करूं कॉल? ठीक, इवनिंग में 9 के बाद करता हूं सर, इवनिंग में 9 के बाद करता हूं। अरे नहीं उठाया था मैंने। हाँ हाँ करता हूँ, यस यस श्योर, जरूर जरूर, यस सर, थैंक यू। Yes, completed.
Yes.
हाँ बेटा,
Yes, sir, done.
अच्छा, you have got vacation from other class also? Diwali
Yes, sir.
vacation or no vacation?
Yes, sir. Got.
Yes, sir.
You have vacation from when to when?
13 to 22.
Yes.
13 to 22. 13 to 22, today is 11th, ना?
Yes, sir.
Yes, sir.
Sir.
अच्छा, एक मिनट, लेक्चर के बाद जाना मत, थोड़ा प्रोग्राम डिस्कस करने आगे। हाँ, कंडक्टेंस हो गया। ग्राफ ऑफ V versus I. V versus I. This is V. This is I. V is in ampere. It can be even in microampere. This is in volts. It is found that graph is straight line passing through origin because I is directly proportional to current. If this angle is theta, what is tan theta? Any specific name for tan theta? Slope, na?
Slope.
So,
So can I say slope of VI graph, which is equals to tan theta, is nothing but resistance?
yes.
Correct, na? Its resistance R. So slope of VI graph is called resistance. What will be 1 upon R called as?
Conductance.
Conductance.
Conductance. So if they give I and V graph, then slope will become conductance, its reciprocal will become resistance. VI graph, then slope is resistance and its reciprocal is conductance. Okay, please copy till this.
Done, sir.
Sir, just a minute.
ये चैप्टर का थियरी इतना डेंजरस नहीं है.
Done, sir.
Done. Okay. Based on this, I'm just giving you one question to identify relation between resistance. Let me see how many of you can manage. RA is equal to RB. RA is less than RB. RA is greater than RB. Data is insufficient. Data is insufficient. Sure. Tell me this relation. What is correct one?
Option C.
So B.
B is correct. RA is less than RB. Correct.
Yes, sir.
Correct. 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 How you could say this?
So this is conductance.
Correct. So you thought slope equals to conductance. Correct, na?
Yes, sir.
So slope of A is greater than slope of B because that angle is greater. That means conductance of A is greater than conductance of B. So resistance of A is less than resistance of B. B is correct option. Very good. If you have done, please tell. Huh?
Done, sir.
Some number, no, sorry, new topic. Limitations of Ohm's law. Limitation of Ohm's law. Limitations means where it will not be true. What is V upon I?
R.
R.
That means if I want to obey or follow Ohm's law, this ratio should be constant, na?
Yes.
Yes, sir.
Yes, sir.
In some cases, this ratio is not constant. That means resistance changes. And further you are going to study, temperature increases, resistance may increase in some cases. In some cases, temperature increases, resistance decreases. So it may be temperature dependent also. Correct, na?
Yes, sir.
Yes, sir.
So can I say Ohm's law is obeyed for those substances where its graph of V and I is a straight line? Correct, na? Graph is straight line.
Yes, sir.
And if graph becomes curved like this, if it is not straight line like this, if it is curved, now this is called ohmic and this is called non-ohmic. Non-ohmic means resistance is not constant everywhere. It is changing.
Variable.
Variable, yes. Write down. Ohm's law is only valid if resistance remains constant. In which resistance remains constant. In some devices, such as junction diodes, this we'll see in chapter called semiconductor. Junction diodes, comma thermistors, comma vacuum diodes, resistance changes drastically with temperature. Hello? Yeah? हाँ बोल रहा हूँ. हाँ? नहीं नहीं मुझे नहीं. नहीं अभी मुझे टाइम नहीं. आप फर्दर क्या करो. Hello? Resistance changes drastically with changing temperature. Hence, Ohm's law is not valid. Hence, Ohm's law is not valid. Next, right? Ohmic devices. Ohmic.
Sir,
Yes.
sir, those 2 points were different or they were 1 point only?
We didn't wrote point wise, na? We wrote in one line, paragraph wise.
Okay, okay.
Ohmic devices. The devices for which potential difference V versus current I curve is a straight line passing through origin are called as linear devices or ohmic devices. They obey Ohm's law. Next, non-ohmic devices. The devices for which IV curve is not a straight line. The devices for which IV curve is not a straight line. The devices for which IV curve is not a straight line are called as not a straight line are called as non-ohmic resistance. They do not obey Ohm's law. They do not obey Ohm's law. This is IV characteristics of non-ohmic resistance. Non-ohmic device, IV characteristics, it is curved. Yes, written. Draw the diagram.
Yes, sir.
Factors on which resistance depends. Factors on which resistance depends. First, you all know that if you have to travel far, then more obstruction will come. So I can say resistance is directly proportional to the length of conductor. Resistance is directly proportional to the length of conductor. So R is proportional to length. Resistance is inversely proportional to the area of cross section of conductor. Therefore, R proportional 1 upon A. See, I'm drawing one conductor. You tell me which part is area of cross section. This, 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 this. Which is area of cross section? 1, 2, 3, 4. Which one is called area of cross section?
2 and 4.
2 and
Two,
4.
yes, sir. One.
Okay. Why not then 1 and 3? See, if this is current flowing, huh? This is current, then this perpendicular is called area of cross section. This is called area of cross section, not 2 and 4. But if current flows like this, then 2 and 4. You got it? Meaning of area of cross section.
Yes, sir.
Chalo.
Sir, can you repeat?
Yeah, I am repeating. I said area of cross section is not decided by the body. It is decided by current. If current is flowing like this, then this part which is perpendicular to the direction of current is called area of cross section. Not followed?
Yes, sir.
Followed, sir.
I have shown here one cube. Can you tell area of cross section is which one? You will say, sir, first tell me where current is flowing. If current is moving like this, then this top and bottom is area of cross section. Current goes like this left right are area of cross section. Understood area of cross section?
Yes, sir.
So not necessary कि पतला वाला is area of cross section. Current किधर से flow हो रहा है, that is called area of cross section. Everybody followed? Hello?
Yes, sir.
Yes, sir.
So if this is area of cross section, this is called length. This side. Length मतलब in the direction of current रहता है. इसका अंदर ये अगर ऐसा करंट फ्लो हो रहा है ऐसा ऊपर से, तो ये वाला पार्ट अपना एरिया ऑफ क्रॉस सेक्शन होएगा और ये वाला पार्ट लेंथ हो जाएगा. मतलब करंट का डायरेक्शन वाला लेंथ, करंट को परपेंडिकुलर वाला एरिया. याद रहेगा क्या ये? इन द डायरेक्शन ऑफ करंट लेंथ, परपेंडिकुलर एरिया.
Yes, sir.
Please feed in your mind properly. In the direction length, perpendicular. What is perpendicular?
Area.
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 Correct. Write these 2 points. First point, resistance is directly proportional to the length of conductor. So R proportional L. Second, resistance is inversely proportional to the area of cross section of conductor.
Done, sir.
Okay. Third point, right? Resistance depends upon nature of material. How it depends, we cannot predict. For some material it is direct, some material it is inverse. More electron density, then less resistance. Fourth, resistance depends upon temperature. Define specific resistance or resistivity. Define specific resistance or resistivity. See, since R is proportional to length and inversely proportional to area, so we can say it is some constant rho L by A, where rho is a constant called as specific resistance or resistivity. Just copy till this, then I'm giving definition.
Done, sir.
So we wrote from vectors are proportional L upon area, rho L by A. Rho is a constant called as specific resistance or resistivity. Same it is continued. Don't make new line. Wait 1 minute. If length is 1 meter, A is 1 meter square, then can I say R is same as rho? Because length 1, area 1, 1 upon 1 is 1.
Yes, sir.
Okay. Thus, specific resistance. Rho means specific resistance is defined as the resistance of conductor. Specific resistance is defined as resistance of conductor having 1 means unit length and unit area of cross section. Unit length and unit area of cross section. Its SI unit is. What is unit of R? Is it ohm? And
Yes, sir.
length is meter, area meter square. 1 meter cancel. So can I say its SI unit is ohm meter? Ohm meter. Now copy to this.
Done, sir.
Okay. One line below this. The reciprocal of resistance, the reciprocal of resistivity is called as conductivity. So sigma is 1 upon rho. Its SI unit is Siemens, because ohm ka reciprocal 1 upon ohm meter is Siemens meter raised to minus 1 or 1 upon ohm meter. Completed?
Yes, sir.
हाँ, थोड़ा यूनिट का आगे लिख देता हूँ. ओम सीमेंस और इट इज ऑल्सो ओम मीटर रेस टू -1 और उल्टा ओमेगा मीटर रेस टू -1. Next, color code for carbon resistors, also called as resistor. What do you mean by code? Meaning of code? Hello? Hello? Can you all hear me? Code means what?
पासवर्ड
पासवर्ड तो कोड मतलब सिग्नल बोल सकते हैं ना, जैसा कोई बोला 1 मतलब याद रखना, स्टडी, 2 मतलब
Sir,
हाँ,
some kind of instruction.
or can I say some kind of notation
Yes,
in terms of some symbol?
yes.
इसका मतलब क्या है? नाइकी, ये सिंबल क्या है, किस लिए ये? ये डेफिनेटली राइट के लिए ना, इतना तो क्लियर दिख रहा है। ये
Wrong.
Wrong.
रॉन्ग, तो एवरी टाइम वी डोंट राइट ना फुल स्पेलिंग, ऐसा सिंबल देख के भी समझता है ना।
Yes, sir.
तो वैल्यू ऑफ कार्बन रजिस्टर का वैल्यू बहुत ज्यादा होता है, तो उसको ना लिखते नहीं है वैल्यूज, उसको कलर कोड से बताते हैं। सो वैल्यू ऑफ कार्बन रजिस्टर इज फाउंड बाय कलर कोड मेथड। हेडिंग यू हैव रिटन, हेडिंग?
Yes, sir.
Yes, sir.
Okay, just write 2-3 lines. Right, the value of carbon resistors are found by color code method. Found by color code method. The value of carbon resistors are found by color code method. In this method, 4 color bands are marked on resistor. Four color bands are marked on resistor. The first 2 colors represents significant digits, meaning I'm explaining significant digits. The third color represents multiplier of integral power of 10, मतलब 10 raised to 1, 10 raised to 2 ऐसे, integral power of 10. And fourth color represents tolerance. Fourth color represents tolerance. The code for different colors are as shown in the table below. Just copy till this, then I'm explaining how to find this. First 2 will give you significant digit, that means some numerical numbers. Third is into 10 raised to factor. Fourth is tolerance, kitna kam kitna jada, or you can say limit of possibility of error. Can I clear the screen now? Hello?
Yes, sir. Done.
Yes, sir.
Oh, okay. Color, then it's code, multiplier, of 10 raised to n, tolerance. B. Roy of Great Britain had very good wife. बाद में लिखाता हूँ फिर से. B. Roy of Great Britain had very good wife. This B stands for black, brown, red, orange, yellow, green, blue, violet, gray, and white. Black stands for zero code. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if black color comes as the third band, then it is 10 raised to 0. This is the meaning. 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, 6, 7, 8, 9. 3 more lines I have to draw for that tolerance. First you make this much. Color, code, multiplier, tolerance is for 3 different color. I am writing below. Black, brown, red, orange, yellow, green, blue, violet, gray, white. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 more lines will come up. You all please write only this much.
Done, sir.
Okay, everybody has done these columns.
Yes, sir.
Yes, sir.
Okay. 3 more lines you have to extend further. Gold, silver, no color. Then directly will come to tolerance wala column. Code, multiplier, tolerance. This is plus minus 5%, plus minus 10%, plus minus 20%. Then example we are seeing. PB Roy of Great Britain had very good wife. P.P. Roy of Great Britain had very good wife. This is how we can remember that coding. We start black, then come to white, last word. Once you complete, please tell, so that with example we'll come to know meaning of this coding.
Yes, sir. Done.
Done,
Everybody
sir.
has done?
Yes, sir.
Yes, sir.
Okay. Examples. First, color codes of resistor are yellow, violet, orange, and gold. We want to find its value. This yellow color, find value. Yellow color, violet color, orange, and gold. These are four bands marked. Yellow stands for which digit? Is it 4?
4.
Correct, 4. And violet?
7.
7.
7. Orange?
3.
3.
Gold means plus or minus 5%. So therefore value is equals to first two digit direct लिख देना 47, then into 10 raised to 3 plus or minus 5% हो गया ये आंसर. Understood meaning? Or you can write 47,
Yes, sir.
10 raised to 3 को किलो ओम लिखा तो भी चलेगा, plus or minus 5%. ये हो गया आंसर. Solve. This year they had asked one MCQ based on color code.
Done, sir.
Okay. Second one. Find the color code for resistor of value 330 ohms. 330 ohms. So 330, can I write 33 into 10 raised to 1? Can we write like this? 330 is 33
Yes,
into
sir.
Yes, sir.
now 3, 3, 1 and nothing here means no tolerance band. 331. 3 stands for which color?
Orange,
Orange. Orange. And 1 stands for
brown.
Brown.
brown. So can I say,
Brown.
yeah, color codes are orange. Second band is also orange. Third band is brown. And fourth band no color because कुछ tolerance ही दिया नहीं है. Or just write this much 3. That's it. No need. Orange, orange, brown. Fourth दिया नहीं तो आप खाली लिख देना tolerance band. कौन सा है we are not knowing. Have you followed now?
Yes, sir.
Yes, sir.
Please solve.
Done.
Done?
Yes, sir.
Then write temperature dependence of resistor. Temperature dependence of resistance. If length is increased, what about resistance? It will increase.
Increase.
Increase, yes.
So in case of metals, it is found that resistance increases with increase in temperature. Let R0, RT be the value of resistances at 0 degrees Celsius and T degrees Celsius respectively. Experimentally, it is found that increase in resistance, that is RT minus R0, higher temperature पे ज्यादा, lower temperature पे कम, तो increases RT minus R0. Hello? Hello?
Yes, sir.
Yeah, please do till this.
Done, sir.
Experimentally, it is found that increase in resistance, that is RT minus R0, RT minus R0 is directly proportional to, first, the original resistance R0, the increase in temperature delta T. Therefore, RT minus R0 is proportional to original resistance into increase in temperature. So RT minus R0 equals to some constant into R0 delta T, where alpha is constant called as temperature coefficient of resistance. Yes, copy this much, where alpha is constant called as temperature coefficient of resistance.
Done, sir.
One more line. Huh? Therefore, RT equals to R0 plus alpha R0 delta T. So RT equals to R0 1 plus alpha delta T. This is temperature dependence of resistance.
Answer.